Okay, today we're going to be talking about zeros and the factored form of polynomial equations. We're going to start with a parabola. Now, if f of x equals ax squared plus bx plus c has the zeros x1, 0, and x2, 0, then f of x can be written as, this is the factored form, f of x equals a minus x1 times the quantity x minus x2. That does not mean make it negative. A minus means subtraction. If I'm subtracting a positive, it will result with a minus in front. If I'm subtracting a negative, it will result with a positive. So it's very important that you understand what the formula says, that you are subtracting the zero. An example of this. Let's say we have this parabola here. That looks something like this. And I'd like to write this in factored form. Right now we're not going to assume what A is. We're just going to put it in factored form without knowing what A is. So to put this in factored form, I would write f of x equals the unknown amount A times x minus the very first x1 would be negative 5. And since I'm subtracting a negative 5, I end up with a plus 5 times the quantity x minus x2, in this case x2, the second x value at the 0 is 1. This is the parabola in factored form. I'm now going to extend this idea to a third degree polynomial function. So, given f of x is a third degree polynomial with a equaling plus or minus 1, and I really should say a naught. In this case, since we're going to a third degree. Now, to make this assumption, when I make this equation, first thing I need to determine is a plus or minus 1, and I determine that because it's a third degree polynomial function going from negative infinity to positive infinity from left to right. All odd polynomial functions who go from negative infinity to positive infinity have a lead coefficient that must be positive. So, since I know it has to be positive and my choices are positive 1 or negative 1, that means A is positive 1. Technically, you don't have to write it out front, but I am just so you can see it. Okay, slide that over a little bit. Now, in factored form then, using the same principle as the polynomial, I'm going to take x minus, in this case, negative 5, making it a plus 5. X minus a 1. And x minus the 3. My 3 zeros of my third degree polynomial function. And this is the equation of this polynomial function in factored form. I am now going to do a third example of putting a polynomial function in factored form. This polynomial, we're going to assume, is a fourth degree polynomial. Now, it has 3 terms, so I know that the minimum degree is fourth degree. It's possible it's a higher degree than fourth, but I know the minimum is fourth degree. I also know my lead coefficient is negative, but I am specifically being told for this problem that my lead coefficient is not plus or minus 1. So it's something else. So I do not know what A naught is, but I do know for a fact it's not plus or minus 1. So we're going to begin the process the same as we did for the second degree and the third degree polynomial. I'm going to start off with f of x. In this case, I do not know what A naught is. X minus the first x value, which I will assume to be negative 3. Since I'm subtracting a negative, it becomes positive. And then x minus my next x value, which is a negative 2. When I subtract a negative, it becomes positive. X minus my third 0, which appears to be about negative 1. Since I'm subtracting a negative, it becomes a positive. And last but not least, x minus what appears to be approximately positive 1. Now, I basically know my fourth degree polynomial function, except for I do not know what my initial constant is. I'm going to find my initial constant by using a technique we're going to use over and over in mathematics. If you are missing one constant in a formula, you need one point that satisfies the equation that you have not used as of yet. Now, I've used this one, this one, this one, and this one. So I would need some other value on the function to solve for my missing constant. I will choose the value 0, 2, my y-intercept. It does not have to be the y-intercept, but it just seems to be a nice clean number that's easy to use. Now, if this fourth degree polynomial in fact represents that graph, then this fourth degree polynomial must give me every point on the graph, including the point 0, 2. Meaning y is 2 when x is 0. Little help from the calculator. Let's see, I have 3 times 2 times 1 times negative 1 gives me negative 6. I'm going to solve for A naught by dividing both sides by negative 6. A naught then is negative 1/3. Now I can write my fourth degree polynomial in factored form. Okay, another example using the factored form of a polynomial. I'm going to determine if k equals negative 3 is a factor. What does it mean for a number to be a factor? That means a couple different ways we can look at it. Basically, that means if I put it in factored form, one of the factors would be x minus that negative 3. And of course, if it's third degree, I'm going to have, what, a couple more factors. Well, a in this case actually would be 1, so we already know that. X minus x1, let's say this is x2, don't really know. What the order is doesn't matter. As many as 3 possible factors, and the question is k minus 3 one of them? I don't have to have it in factored form to determine this. If something is in fact a factor, what that means is that's a point on the graph. So if k equals negative 3 is a factor, then negative 3 times 0 must be a point. How do I determine whether something is a point on a formula? I use the formula. I'm going to plug in negative 3 in any form. It does not matter what form I use a formula in because it's the same formula. So I do not need it in factored form. I'm going to plug in f of negative 3 and see what happens. Good time to pull out the calculator. The real question is, does this amount equal 0? Yes or no? So, here we go. Turn on my calculator. I'm just going to take negative 3 and store it as x. After I do that, I got what? X cubed plus x squared. Oops. Don't need that. Gotta come down there. Plus x squared minus 14x minus 24. Hit enter and I get yes. It equals 0. Question was, does f of negative 3 equal 0? The answer is yes. If f of negative 3 does in fact equal 0, then k equals negative 3 is a factor.